This is the MultisimLive tutorial for the Electrical Circuits Lab. What you see here is the web page that should come up when you go to multisim.com. You will first need to sign up by filling all the information on this web page and creating an account. Once you have done that, you will have a Universal National Instruments account, which means that you will be able to access all their platforms and services and download products such as LabVIEW or Multisim, the desktop version. If you have an account already like me, you can just log in. Once you log in, you'll find yourself in your personal profile. Let's jump into creating a circuit by pressing Create Circuit right there. This right here is your working space where you will place all the circuit components. Let's give the circuit a title and jump into creating a circuit that has some resistors, a voltage source, and a current source. On the left side right here, you will find various categories of real-life components, such as sources, resistors, and diodes. I need a voltage source, so I'll go to Sources, click, and you can see there are various kinds of sources. I need to create a DC circuit, so I'll pick the DC voltage source. So I click it and I hover my mouse where I want to place it right here. And now you'll see that there are 4 buttons that pop up. They all allow you to manipulate the placement of the component. So for example, I can rotate the component, I can flip it, I can copy it, and I can delete it. I can also change the component ID. For example, I'll just write here voltage, and I can change the parameter value. So I want my voltage source to be 20V. Now, you can either drag this indicator right here, and I guess this is useful for tablets if you're using this platform on a tablet, but you can just directly input the voltage using this as well. So let's bring all the circuit components to the workspace. I need a current source, so I can go to the sources category, or let's say I don't know where my component is or under which category it falls. I can just go to the search function, and from here I can say current, and as you can see, I'm not really specific, so I'm getting a lot of options. If I say DC current, because I'm creating a DC circuit, there you go. There's a DC current source. I can take it and place it where I want to place it. All is left is some resistors. Go to the passive category, get some resistors. I'll copy it. I want 2 resistors and I'm going to connect them in series, so I'll put them this way. Now all that is left is to connect the components to create the desired circuit. And you can do that by going to one component's end, clicking and releasing, and then going around to the next component end. And Multisim does a good job in creating a reasonable path for the wire. But let's say that you want to create your own path. You can do that by clicking, releasing, and then going anywhere you want, clicking uh, at the point where you want the wire to turn. There you go, and then clicking again, and then clicking like that, and then you can just create whatever path you want. Of course, I don't want a path like that, so if you want to delete the wire, you just click on the wire between 2 components and then either press delete or click on the X button. So let me make the connections really quick. I want the resistors to be 100 ohm resistors, so and I want to make the current source value 0 because I want to see how the circuit behaves without any current source first. Now, I want to define some measurement points to analyze the circuit when I run it. So I want to make a voltage measurement. I'll go to the analysis category of the component bar and I'll select voltage and I'll place the measurement here. So what this will do is it will give me the voltage at this point of the circuit with reference to the ground. Now, if I want to change the reference point of this measurement, all I have to do is click on the measurement probe, click on the Add Reference Probe button, and place the reference wherever I want it to be. So now the measurement here will be with reference to this point. I'll add some current measurements as well. So I wanted to have one in this branch, and one in this branch, and one in this branch. And I'll put it here. Okay. Now, as you can see, there is an arrow pointing to the direction of the current measurement. So what that means is that if the value is positive, then the current is going through with the direction of the measurement. If it's negative, then it's going against that. Let me delete this new reference point that I placed for the voltage measurement. So now this voltage is going to be with reference to the ground. Let's run the circuit and see what measurements come out. To run the circuit, you just have to go to the simulation bar and click on the arrow button. You can see that it's running in real time. So in here, we have 100 milliamps going through in this direction. We have 0 amps going through in this direction. And we have another 100 amps going through this direction. Actually, it's the same 100 amps because this is in series. And 10 volts at this point with reference to the ground. Now let's stop the simulation and change some parameters to see their effect on the results of measurements. So I want the current source to produce 2 amps. You can see how the message of out of date came out of all the measurement probes, which means that whatever measurement you see in here does not represent this circuit architecture or the components values in here. So let's run the circuit again and see what we get. As you can see, now we have negative current in here and negative current in here. What that means is that the current is going against the direction that is pointed under the probe. So the current has reversed and is going back this way. And also it's going all the way down here. Now I want to perform a DC voltage sweep. I want to see the effect on all these measurements when the voltage of the voltage source is swept from -10 to +10V while keeping all the other parameters, the resistors, and the current source the same. To do that, we have to change the simulation mode from interactive to DC sweep. And you can see here in the simulation bar, the mode is now on interactive. We go down the drop menu and click DC sweep. Now we need to go to the simulation settings to change the sweep parameters. So what sweeping is implied in its name. What we want to do is to use the effect of different voltages at a specific increment. Let's make that 1 volt interval from -10V up to 10V. The simulation then will run the circuit with the voltage source at -10V, taking all the measurements at this state. Then it will run again at -9V, then again at -8, all the way up to 10V, taking the measurements of every iteration of the voltage source. So the simulation basically sweeps through the voltages at the defined increment. So let's define the start value in here. We said we want to start at -10V, so we go to the start value We put -10. It's a little slow. And then the stop value, it's going to be 10 because we said we want to stop at +10. And we said we want the increment to be 1 volt. If I make the increment value 2, then the measurement will be taken for every 2 volts, -10, -8, -6, etc. Let's run the simulation and see what happens. You can see how Multisim immediately switched from the schematic tab to the grapher tab. In here, you can get a visual of the effect of increasing the voltage and all the parameters that you have chosen as represented in the legends. Sometimes the graph doesn't show up properly. Sometimes the limit of these axes are way too low and the graphs extend beyond what you see in here. And to fix that, you can simply just go to the right pane right here. And let's say that I wanted this axis to go from 0 to 20 or from -10 to 20. I can just go to the corresponding window, voltage, which is conventionally the x-axis, voltage here. I can do 20. There you go. Now, obviously, I didn't take measurements above 20 volts, so there's nothing graphed in here. But this is just for demonstration. You can also adjust the left axis and the right axis from their corresponding windows here on the right pane. I have the legends on the top right to identify the graphs, but it's easy to forget where exactly the measurement point was. So what you can do is put the split view on, and now I can simultaneously see the graphs and the schematic to identify which line or which graph corresponds to which point. Let's take this line over here, for example. It's the gray line. Obviously, it corresponds to the gray probe or the current behavior at this point. The green line also for the voltage, and etc. Let's say I want to know the exact measurement at a single voltage point from the voltage source. I can easily do that as well just by hovering over the graph. I can get discrete points of measurements for every trial. It's very useful. If I want to save this work, I can go up here to the File Navigation menu, and I could either choose Save As, which will save this work to MultisimLive Cloud, and from there I could access it from any device that supports or from any device from which I could access MultisimLive. Or I could export this work to various formats, such as National Instruments Multisim 14, which is the desktop version, or an image, or CSV, etc. There are plenty of options and features that this platform provides, but what we have gone through should be all that you need to complete the lab task. I encourage you to play around with this tool and also navigate MultisimLive page and their platform to see all the interesting things that you